Good afternoon everyone and welcome to my YouTube channel. So here today we are going to be looking at adding vectors by analytical method. So what are some of the things that we need to know? So the first thing that we are going to look at is how you identify a certain vector. Let's say it says that 28 degrees west of north. So you are required to know how you are going to identify this angle. So on your Cartesian plane, which looks like this, you know that your north is here, your east is here, your west is here, and the south is down there. So how do you identify 28 west of north? So this means to say we are going to draw a line. Since the north is up there, west is this side, we are going to be going up while going to our left like that. So this is the angle. Now how do you identify where the 28 is? So this means that for you, the last side mentioned is where you are beginning from. So when we say west of north, it means to say begin from north and go until you meet the line. So that means to say your 28 degrees is here. So let's look at our second one. Let's say we are looking at 54 north of west. So this simply means to say we are going to have our Cartesian plane like that. Then we are going to draw north of west. It means to say go up while going to your left. So the vector will look like something like this. Now north of west means begin from the west, then go towards the north. So we know that our west is here. So begin from the west and go to the north until you meet the line. So this means that the angle 54 degrees is here. So the 54 degrees is here. So let's look at our next one. So if we look at this one, we are going to have our east of north. This simply means to say go, we have north is up there, east is here. So we are going to be going up while going to our right. That's where the direction is. So now east of north means that begin from the north, go to your east. So whatever is mentioned at the end, that's your last angle or angle of reference. This means to say the 28 degrees is here. So it's very simple to identify the angle. So same approach, our north of east is going like that. Then we know that north of east means begin at east. We know our east is here. Go up until you meet the line. You are going towards the north. So this is where our 54 degrees is. When we look at this one, we have 60 degrees west of south. It means to say we know that our west is here, south is down here. We are going to be going down like that because we already know to say we have our south, which is going down, our west is going down. So we are going to be going down in a diagonal way. Now if we say west of south, it means to say begin from your south, which is here, go towards the north. Go towards the north until you meet the line. So this means that the 60 degrees is here. This is very crucial when answering vector questions. So let's look at this one. Let's say we have our 30 degrees south of west. So we know that, let me at least put it somewhere here. So south of west simply means to say south is there, west is here. So south is down here. So go down while going to your west like that. Then we are going now to combine. South of west means begin from your west, which is the west line is this one. Go until you meet the line going towards the south. So this means to say our angle of 30 degrees is here. Let's look at our last two. So let's say we are looking at our east of south. So what does this mean? So east of south means that we are going to draw. So we know that our east is here, south is down here. So our general direction will be that it will be going down like that, because that's where the direction of east is. So going down while going to your east. Then 20 degrees east of south means begin from the south, go towards the line where the east is. So we are going to draw something like this. So this means to say this is where our 20 degrees is. Last but not the least, if we have our 40 degrees east south of east, it means to say the line is the same. Go down while going to your east. Then 40 degrees south of east means begin at the east, then go towards the south. So this means to say this is our 40 degrees like that. So one other important thing is that under vectors, we always measure angles from the positive x-axis. So what do we mean by that? So let's say we have a vector like that. Let's say here it is 20 degrees. So in order for you to, since vectors, the direction is important, it means to say you have to account for the angle. So the angle that you're going to be using in your calculations should be measured from the positive x-axis. So that means to say if you're looking at this situation, you are going to be measuring the angle from the positive x-axis here, going clockwise like that until you reach your angle. This means to say the angle that you will be using in your calculations will be this angle. And if we know to say this is a straight line, meaning to say it is equal to 180, so we can say, let's say we name this as our x. When we say x plus our 20 degrees should be equal to 180 degrees. So our x is equal to 180 degrees, then minus 20 degrees. So we are going to have 180 minus 20 degrees. It will give us 160 degrees. So this is our x. So we are going to be using angles measured from the positive x-axis. So likewise, if we have such a situation whereby we have something like a 40 here, we are going to be using angles measured from the positive x-axis, which is going to look like something like this. So it will be measured until you reach that angle. So now remember, this angle is more like it's adding up. So we are going to say, in order for me to find my angle, which is my y, I will say y is the whole angle, which should be equal to, if I know to say this is 180, I'll be able to say 180 degrees plus 40 degrees. If I add the two, I'll have a 220 degrees like that. So this is my y. So angles are always measured from the positive x-axis, which is very, very important. So likewise, not forgetting the Pythagoras theorem, we remember that if you have a side, that looks like this, we have such situations, we can be able to say if we have sides such as 3, 4, to find the missing side here, which will just be a 5, we know to say, let me call this one as our resultant. We know to say resultant should be equal to the square root of our rx squared plus ry squared. As you are used with Pythagoras theorem, you are going to say maybe c squared is equal to a squared plus b squared, which is just the same. Now here we are just saying that the x component plus the y component squared will give you your r. So in this case, our r should be equal to, which is our resultant, in this case it is our c. Even here, when you make c the subject of a formula, introduce the square root, it will be c should be equal to the square root of a squared plus your b squared. Now likewise, we are going to say this will be our square root of our rx. This is the x component, which we are going to say 3 squared plus our 4 squared, which will be our r should be equal to our 3 squared is 9 plus our 4 squared is 16. So when we add, our r should be equal to 9 plus 16 will give us a 25. So square root of 25 will give us a 5. So this is our r. So after analyzing this, we are going to be using this approach. Now the only problem with answering problems that are dealing with the analytical method, we are going to be having many r values. So meaning to say, we need to know now how to add those r values. By adding them, then we can find the resultant in the x, whatever it will be. Let's say it's 5, then the resultant in the y after adding, which will be, let's say, a 7. Then you square both of these to get your final resultant distance or whatever you are looking for. So let us now be able to answer problems. So now, remember, if we have something that looks like this, we have a right angled triangle like that. If we have the angle theta here, then the opposite side, which is there, let's say we have A and our B, then we have the resultant R. So we can say that in order to use, let's say, the sine of the angle, we know from trigonometry, we say that the sine of theta should be equal to opposite over hypotenuse. Now in this case, our opposite is B, so we are going to say sine of theta should be equal to our opposite, which is our B, over the hypotenuse. In this case, it is our R. So each and every time we are looking at the opposite side, or rather, when you look at this one, your B here is actually the y component, because we have, if we look at the Cartesian plane, we are going to be having our x and y, So whatever component is going up like that, it's your y component. Whatever component is going down, it is your x component. So okay, let's use even x and y so that it's much easier. So we have our y components like that. Then we are going to do a cross multiplication. We are going to find that r will multiply the sine of theta to give us a y. So now what does this tell you? Each and every time you're looking at vectors, you are always, the y component should always have the sine of theta. Likewise, even the x component, we are going to use cos. So if you look at this one, the x component is here because this is the adjacent. So we can say that the cosine of theta should be equal to our opposite over hypotenuse, like that. Sorry, cos is adjacent. Now the adjacent to this, for this type of system, it's the cosine of theta should be equal to our adjacent, which is our x in this case, which is the base with respect to this angle. Then we have over the hypotenuse, which in this case is our r. We are going to also cross multiply. We are going to have our r cosine of theta, which should be equal to our x. So now, the x component is associated with cos, the y component is associated with sine. So if we are adding vectors, we are just going to be saying that the rx plus the x component, we are going to add them throughout like that. That's very, very important. So let's now solve this problem. So let's say we are looking at this problem. 3 vectors are shown in figure 2.8. Their magnitude are given in arbitrary units. Determine the sum of the 3 vectors given the resultant in terms of components. Meaning to say we must give the resultant in terms of the rx and the ry. Now the problem here is that we have a lot of components in the x already. We can identify to say this one, as it is going like that, it also has got an x component. So it's more like it's looking like this. So there are many ways of adding these vectors. However, others will use a table, but I feel like the table wastes time. So what we are going to be using is we are just going to separate these in 2 components. So remember everything that I have already taught you to say. The x component is associated with cos. So we can say resultant in the x. So resultant in the x, remember the formula I gave you. As long as you are dealing with x, we said that it is equal to the r cosine of theta. But there are a lot of r's and there are a lot of thetas, so we can differentiate them. So what we are going to say, the resultant in the x should be equal to, we are going to say r1 cosine of theta 1 plus r2 cosine of theta 2 plus the r3, then the cosine of theta 3, so that we distinguish each and every component. So what we are going to have is, what is our r1? So if you look at our r1 from the diagram, we know that our r1 is equal to, so the r1 in this case is equal to this one, which is for our a, which is 44. Then the cosine of the angle, which is just this one. So we are going to say 44. Then we are going to say cosine of the angle, which is equal to, what's our angle? Our angle is 28 degrees. Then we are going to add plus our R2. Our R2 is equal to, if we look at here, we have 26.5. So we are going to say R2, which is our 26.5. Then we are going to say the cosine of, now here you need to be careful. We have 50 degrees here. So this is not the one. We always measure angles from the positive x-axis. So that means to say the angle that you will use, it should move from here up to here. So by doing that, it means to say you have accounted measuring the angle from the positive x-axis. So if this is 50 and this is a straight line, to find, let's say, our angle y here, we are going to say our y should be equal to 180 degrees minus our 50 degrees, which will be 130 degrees. So we are going to put our 130 degrees there. So we have 130 degrees there. Then we have plus. We have our R3. So here, if you look, if you want, you can use 50, but you have to attach a negative. But to avoid that, just use the angles measured from the positive x-axis. Now, if you look at our last one, our C, we are going to say our C should be equal to, our size is 31. So we are going to say 31 cosine of, if you look at the size of this angle, we are going to find that it is equal. So the angle is measured from the positive x-axis until you reach this point. So this angle is a 270. So this is 90, 180, 270. So we are going to put the cosine of 270 there. So we have the cosine of 270 degrees. So you are going now to be pressing on your calculator. So we are going to find our 44 cosine of 28. So our 44 cosine of 28, this one is giving us a value of 38.85. Then we have plus 26 cosine of 130. This is giving us a negative 17.0338. Then we have plus our 31 cosine of 270. The cosine of 270 is 0. So everything, when you press 31 cosine of 270, you are going to get a 0 degrees. When we subtract the 2, we are going to find that we are getting a 21.82. So this is our resultant in the x. After finding our resultant in the x, we can now say resultant in the y. So in the y, we are going to say our resultant in the y, which is our ry, should be equal to r1, same concept, but the resultant in the y is associated with the sine of theta. So r1 sine of theta 1 plus r2 sine of theta 2 plus our r3 sine of theta 3. So yeah, let's just what we are just going to do is we are going to use our x to help us. So we have our ry, which should be equal to, we have our ry, which is equal to a 44. So we are going to say 44, which is this one, which is our a 44. Then we are going to put our sine of the angle measured from the positive x-axis, 28 degrees. Then we have plus The other one is our R2. Our R2 is equal to 26.5. Then we have the sine of the angle. So we measured this angle from the positive x-axis. We got a 130 degrees. Then we are going to have plus we have a 31, which is this one, 31, with the sine of the angle measured from the positive x-axis. We have a 270 degrees. So let's press. So our 44 sine of 28, this one gives us a 20.66. Then our 26.5 sine of 130 degrees, this one is giving us a 20.3. Then when we press our 31 sine of 270, we're getting a negative, the same value, 31. Then when we subtract this, we are going to find that our resultant is equal to a 9.96. So this is our resultant in the y. So they asked us at first to find the resultant in terms of components. So we said that our Rx, we found it to be, so for our first part where it says resultant in terms of resultant components, this is what it is giving us. Our Rx is equal to this, our Ry is equal to this. So as they said, we have the resultant, the components, these are the components, then magnitude and angle with the x-axis. So we are going to say our R, which is our resultant, we are just going to use the single letter. So our R should be equal to the square root of our Rx squared plus our Ry squared, as I taught you. So we are going to say the square root of what is our Rx. So our Rx is 21.82. We square this, we add it to our 9.96. Our 9.96. This is going to give us plus our 9.96. Then we find squared. We have now the square root like that. So our resultant will be equal to, so when we square 21.82, we are getting a 476.11. Then we add plus our 99.216. It will be 99.2016 when we square this value. So we are going to find that our resultant, when we do everything, we are going to get a, so our resultant, according to this, when we add, we are getting a 23.96. So this is our resultant. So now how do you find the angle? So the angle looks like something like this. So the angle, we are going to be using the tangent of theta should be equal to our opposite over our adjacent. This is according to the trigonometric ratio, where we are going to be having our tan of theta. In this case, if we have a right angled triangle like this, we have a right angled triangle, our tan of theta will be associated with opposite side, which is this one. We are going to name it as our y. Our other side, we are going to name it as our x. So already your opposite will be y, your adjacent will be your x. So we are going to say the theta should be equal to tan inverse of the y component over the x component. So this is what we are going to do to find the angle. So our theta should be equal to tan inverse of what is our y. Our y, we found it to be 9.96 over our x, it was a 21.82. So we are going to put this in brackets. So when we find the inverse, we can say theta should be equal to a 24.53 degrees. So this is our theta. So that means to say we have answered both the magnitude and the angle. So let's look at this other one. So Bwalya walks 200 meters in the direction 20 degrees east of north. He then walks 320 meters in the direction 41 west of north. He further moves 100 meters at 5 degrees west of south, and then 650 meters at 69 degrees east of south. What is the magnitude and the displacement? So the first things first, let's be able to draw our x or y plane. So our 20 degrees east of north means we know our north is here, our east is here. We are going to be going in this direction like that. Then the important key is that we have east of north. So already we have east of north, meaning to say we begin from north, go towards the east until we meet the line. So this means to say our 20 degrees is here. Let's look at our next one. It says that it then walks 320 meters in the direction 40 degrees west of north. So north is here, west is here. It means to say it will be going up while going to the west like that. So it's something that is looking like this. Now they have said that 40 degrees west of north. So where is the 40 degrees? We begin at our last, which is our reference point. We begin at the north and move towards the west. That's the meaning. So this means to say the 40 degrees should be here. When we look at, he further moves 100 degrees at 5 degrees west of south. So west of south, we have the south is here, then we are going to have something like this. Now our west south is here, so west is here. We are going to be moving in this direction. Now 5 degrees west of south means to say begin at your south, go towards the angle. So meaning to say our 5 degrees is here. So our 5 degrees is here. Last but not the least, we are told that then 650 meters at 69 degrees east of south. So we have 69 degrees east of south. So east of south, east is this side, south is down. So it means to say to combine them, we are going to be moving towards the east but going down like that. Now east of south means begin from your south, go towards the east. So the last letter mentioned, the last thing mentioned is your reference. So this will be where our 69 degrees is. So after doing that, we can now be able to make the calculation. Same approach. So we are going to first find the x components. So resultant in the x. So the resultant in the x looks like this. So the resultant in the x, we have 4 angles. So we are going to have 4 of them. Let's just label them. So we have labeled our 1, our 2, our 3, and our 4. So doing this, we can now be able to say the resultant in the x should be equal to, we are going to say r1 cos of theta 1. Remember, the x component is associated with cos, plus r2 cos of theta 2, plus the r3 cos of theta 3. Then plus our r4, then the cosine of theta 4. Then we are just going to be replacing from now. So we have our r1. We know that our r1, which is equal to 200 meters, which is that one, not 200 degrees, but 200 meters. So we are going to say 200 meters. Then we attach the cosine of our angle. Now remember, our angle should be measured from the positive x-axis. So if this 20 is not the one that we are going to use, so from the positive x-axis, it's from here up to here. So this angle is equal to, if all of this is 90, to find this angle, let's say I name this angle as my x. I can say x should be equal to 90 degrees minus 20 degrees, which will give me a 70 degrees. So I'll put my 70 degrees there. 70 degrees. Then we have plus. What's our R2? Our R2 is at 320 meters. So we are going to put 320. We are going to say 320 cosine of our angle. Now our angle measured from the positive x-axis we are looking at, so if we have here, we have a 70 degrees. So we are looking at the angle from here up to the second part. Now how do we find that one? So already from here up to here it is a 90 degrees. So what we are going to do is we are going to add 90 plus 40, which will give us a, we can even just show it here. So from the distance from here to here in terms of the angle, if here it is 90, here it's 40, we are going to add them. So we are going to add them. So when we find that it's 90 plus our 40 degrees, which will give us our 130 degrees. So we are going to put our 130 degrees there. Then we are going to have plus our R4. So our resultant number 4 is equal to, our resultant number 3, we are a bit ahead. So our resultant number 3, which is this one, is 100. Then we have the cosine of our theta. Our cosine of theta, which will give us, so if we are looking at that one measured from the positive x-axis, it will look like something like this. So it will move until it meets the line. So now we know to say already here it is 180 degrees, here it is 5 degrees, and we know to say this part is a 90. So what we are going to do is, we already know to say just this straight line, it gives us 180 degrees. We are just going to add it with whatever this value is. But instead of doing that, it's more like the only part that we are excluding in this angle, it is a 5 degrees. And we know to say the angle from here, if we move until we reach this point, it is equal to 270. So what we are going to do is, we are just going to subtract 5 degrees. So which will give us, if we subtract our 5 degrees, it will give us a 270 minus 5 degrees, it will give us a 265. Then after our 265, we are going to add plus. Our resultant number 4 is 650. So we are going to say 650. Then we are going to attach the cosine of the angle. So we know to say this is 69. And the angle, let's just redo this one. So we have something like this. It's moving like this. We know that from here up to here, it is a 270. Then we have a 69 here. So to find the angle measured from the positive x-axis, which is the angle from here until you meet your point, we are going to add 270 plus a 69. So our 270 plus our 69 will give us a value of 339 degrees. So this is what we are going to put here, 339 degrees. So that's our angle measured from the positive x-axis. So what we are going to do now is, we are going to add them up. So our 200 cosine of 70 degrees will give us a 68.4. Then we add it. Then when we enter our 320 cosine of 130, it should be equal to a 205. In fact, it's giving us a negative. So we are going to say negative 205.69. When we enter our 100 cosine of 265, this one is giving us a negative 8.772. So this is the goodness about doing things using the positive x-axis. It actually gives you the sign. So our 650 cosine of 339 degrees, this one is giving us a 460.82. So when we add 68.4 minus this, not that, we are going to get a 650 cosine of 339. It's giving us a 606.83. So when we add them, we are going to get a 460.82. So this is our resultant in the x. So looking at the resultant in the y, we are going to use the same approach. So we are going to say this should be equal to r1 sine of theta 1 plus our r2 sine of theta 2 plus our r3 the sine of theta 3. Then we have plus our r4 sine of theta 4, like that. Then we are just going to replace. So now our y and our x components will be using the same numbers. The only difference is the cos. So we are going to use our x components to come up with our y. So we are going to say where there is r1, we are going to put a 200. Then we have the sine of theta 1, which is our 70 degrees, plus our r2, which is a 320 sine of our 130 degrees. Then plus our r3, which is 100. Then we have the sine of 265 measured from the positive x-axis. Then we have plus our r4, which is our 650. Then we have the cosine of, let me wrap that a bit. So we have the cosine of 650, not the cosine. We are going to be using the sine since we are looking at the y component. Sine of 650, sine of 339 degrees. So when we press our on the calculator, 200 sine of 70, we are getting 187.94. Then we have plus our 320 sine of 130, it's giving us a 245.13. Then 100 sine of 65, this one gives us 265, gives us a negative 99.62. Then we have our 650. So we have our 650 sine of 339. This one also is giving us a negative 232.94. So after that, we are going to subtract the two. We are going to have, when we add these and subtract everything, our resultant is giving us 100.51, like that. So meters. So this is our resultant in the y. So our resultant in the x is equal to 460 according to what we found. 0.82 is our resultant in the x. Our resultant in the y is that. So to find the magnitude, we are going to say r should be equal to the square root of our rx squared plus our ry squared, like that. So we are going to have the square root of our x component, which is our 460.82 squared, then plus. So our y component, we found it to be 100.51. So we are going to say 100.51, then we square it. So we are going to have 460. We have our 460.82. We square it. So when we add the square of these both numbers, we are going to have a 222,457.3325. So the square root of this value gives us, so we are going to find the square root of this value. We are getting a 471.65. So this is our resultant. So we are just remaining with the angle. We said that the angle theta is equal to tan inverse of the y component over the x component. So we are going to find that our theta should be equal to the tan inverse of our y, which was 100.51, over our x component, which was our 460.82. So when we find the inverse of these numbers, we are going to get a, so we have the tan inverse of 100 point this, divide by that, it will give us a 0.22. So when we find the tan inverse of this value, we are going to get a theta to be equal to 12.3 degrees. So this is how we find values with such a problem. Thank you very much for watching my video. Hope you like, subscribe, and share for more.